In this video, we are going to look at a few other types of equations. We will look at the equations where there's no solution, linear equations, and we'll also look at linear equations where there's all real number solutions, and then we'll move on to absolute value equations. Okay, so this is the second part of linear equations, solving linear equations. All right, so equations with no solution and all real number solutions, that's our main topic. First, we will focus on equations with no solutions. Okay, equations that have no solutions. There's no number that you can plug in for the variable that would make the left and right hand side equal to each other. When you're trying to solve such equations, what happens is we end up with something like A equals B, where A and B are different. They are not really equal to each other. We might end up with like 5 equals 3. We might end up with 0 equals 2. We might end up with negative 3 equals, something like 7. So we might end up with something that's not really true. And that tells us that there's no solution to this equation. Let's look at a couple of examples. So when we're solving equations, the first step we want to do is we want to combine the like terms on either side. On the left-hand side, I do have these like terms. 12 take away 8 is 4 plus 2x. And the right-hand side, I also have like terms. 7x take away 5x, which is 2x when I combine these like terms plus 5. Now my goal is to bring the variables on one side, so it doesn't really matter which side you take your variables to. So I'm going to subtract a 2x from both sides. It will leave me with the 2x, and 2x is gone. The variable disappears. In all these equations, the variables are going to disappear. Both no solution type equations and all real number solution type equations. So there's no more variable left. I am left with 4 equals 5, and which I know is not equal. So that means there's no solution to this equation. No matter what value, what number you plug in for the variable, your left-hand side and right-hand side are never going to be equal. So that's first example for an equation that has no solution. Let's look at example number 2. 3x plus 8 equals 3 parentheses x plus 2. All right, no like terms to combine on the left-hand side, but on the right-hand side, I do have a distributive property. So 3x plus 8 equals 3x plus 6. 3 times x is 3. 3 times 2 is 6. So 3x plus 6. Now my goal is to bring the variables on one side. So I'm going to subtract 3x from both sides. And as we can see, the variables are gone. We don't have any more variables left. All we are left with is 8 equals 6, and which is not true, and that is not true. That means there is no solution for this equation. There's no number that you can plug in for the variable that would make the left and right hand side equal to each other. Here we are with example number 3. There's the variable y, so all these are y's here. Sometimes y's can look like 4s, but these are y's. On the left-hand side, there isn't anything, but the right-hand side, I got some work to do. First, I'm going to start with the distributive property. So 3 times y is 3y, and 3 times 4 is 12. And I'm not going to distribute 3 into y because that y is not in the parentheses. That is separate outside of the parentheses. Let us go ahead and combine the like terms inside the parentheses on the right hand side. 3y and y are like terms. That comes out to be 4y plus 12. So there's a hidden 1 in front of this y. So we can combine the coefficients here. 3y plus 1y is 4y. 4y plus 12. Next step, we are going to isolate. Before we can isolate the variable, we need to distribute this 2 inside. Distributive property on the right hand side. So leaves me with 8y plus 12 times 2 is 24. Last step, I want the variables on one side, so I'm going to try to subtract 8y from both sides. That leaves me with 0 equals 24, and that is not true. So again, if we end up with a statement that is not true, that means there's no solution to that equation. There's no solution to this equation. All right, second type of equations I'm going to cover in this video are the ones where solutions are all real numbers. That means No matter what number you plug in for the variable, you can plug in 1, 2, 10, 2.5, negative 37, any number you want, the left and right hand side will always be equal. In those, when you're trying to solve them at the end, the variable disappears and we are left with an identity. Okay, we're left with something that's equal to itself. So A equals A or B equals B. For example, we would be left with 0 equals 0 or 5 equals 5 or 2 equals 2 or negative 3 equals negative 3. Something that's always true. All right, let's look at first example. Now, for my first example, on the left-hand side, I do have like terms 5x minus 4x, which is equal to x plus 3 equals 3 plus x. You can stop at this point and see that both left and right-hand side are equal to each other. And this is always true because it's an identity. Both sides are equal to each other. You can stop at this point. But if you feel like you want to continue more, you can try to bring the variables on one side. So that will leave me with 3 equals 3. And that 3 equals 3 is always true. So if you're left with an identity, that means this equation solutions are all real numbers. This is a symbol for all real numbers. So solution is all real numbers. No matter what number you plug in for x, both left side and right side are going to be equal to each other. If you have a doubt, you can always check your work. To check, you can try to plug in any number for x on both sides. So let me just try to plug in x as 2. So that'll leave me with 10 plus 3 minus 8 equals 3 plus 2, which is 13 take away 8 is 5 equal to 5. So that works. How about x equals negative 1? So that's negative 5 plus 3. Negative 4 times negative 1 is plus 4 equals 3 minus 1. So 7 take away 5, 2 equals 2. Works. How about x equals 100? Try it on your own. And you can try a few more numbers, fractions, decimals, any real number. They all will work. Left-hand side and right-hand side will always be equal to each other. All right, example number 2. Let's check that out. So here's our example number 2. Looks like there is some simplifications I need to do on the left-hand side, and there's also some that needs to be done on the right-hand side. Let us distribute 5 inside, use the distributive property. Keep in mind, 5 will not be distributed to 42. 42 is not in the parentheses, so no distributive property applies there, so do not distribute 5 to 42. Turns out to be 5 times x is 5x. 5 times 7 is 35. Let me write it a bit neater here. 5 times 7 is 35 plus 42 equal to 3x plus 2x is 5x plus 7. Now again, on the left-hand side, I do have some like terms that I need to combine. 5x plus 7 equal to 5x plus 7. At this point, you can see where I'm heading. My left-hand side and right-hand side are equal to each other. So that is an identity. But if you want to go one step further, bringing the variables to one side, you can do that. And now this is always true. That means the solution is all real numbers. No matter what real number you plug in for this variable, your answers will be left-hand side and right-hand side will be always equal to each other. So this solution has infinitely many solutions, okay? And what are those solutions? Those are all real numbers. You can plug in any decimal, any fraction, any integer, any real number, they all will work. Here's example number 3, and check if this equation has one solution, two solutions, or actually one, none, or all real numbers. So check if the equation has one solution, no solution, or all real number solution. All right, looks like it's a bit of work, so let's start from innermost parentheses on the left-hand side. I'm going to leave everything else as it is. 1/4 y times 1/4 times 4y will just leave me with the y because 4 and 4 will cancel. 1/4 times 8, 1/4 of 8 is 2 plus 3y plus 7 equals right-hand side distribute 3y. Distribute 3 inside the parentheses, so that's 3y plus 3 plus 5y. A little bit more simplification on left and right hand side. So let's go ahead and finish that up. Y plus 3y is 4y minus 2 plus 7 equals 8y plus 3. 4 times 2, let's go ahead and distribute. Now in the parentheses, distribute the 2 in there, distributive property here. Again, 2 will not be distributed to 7 because that's outside of your parentheses. Okay, so 2 times 4y is 8y minus 2 times 2 is 4 plus 7 equals 8y plus 3. 8y, 7 take away 4 is 3 equals 8y plus 3. Again, at this point, you see where we're heading. It's both left and right hand side are equal, and they're always going to be equal. If you wish, you can go one step further and see that 3 equals 3, which is always true, and that's called an identity. An equation like this is called an identity because both left hand side and right hand side, although they look different in the first instance when you look at them, but they're exactly same things. So your solutions will be all real numbers. So there's infinitely many solutions. Infinitely, I try to combine two words here. There's infinite solutions. That means you can plug in any real number here. Infinite number of solutions. All real numbers work here. Next type of equations we are going to look at are absolute value equations. Absolute value equations, before we discuss absolute value equations, let's first discuss what is absolute value of a number. Absolute value of a number is its distance from 0 on the number line. How far away is that number from 0 on the number line? So what's the absolute value of negative 3? How far away is negative 3 from the number line? Well, it's 3 units away. Okay, so the absolute value would be 3. And if I am dealing with 5 take away 2 absolute value, so first I need to simplify 5 take away 2 and then find the absolute value of that number. Okay, so again, simplify within the parentheses. Absolute value is treated like a set of parentheses. Okay, keep in mind we've done order of operations, so you want to simplify inside the parentheses first before you take care of absolute value. So when we're solving absolute value equations, of course, these are the equations that have absolute value in there, absolute value symbol in there. Before we can get to absolute value symbol, our goal is to isolate the absolute value symbol on one side and then split into two equations without the absolute value symbol. So remember, anytime you're solving an absolute value equation, you want to isolate the absolute value and then split into two equations without the absolute value symbol. Here's our first example. My first step is to isolate the absolute value. Isolate the absolute value. Okay, so I have 1/3 absolute value of x minus 4 equals 5. If I want to isolate the absolute value, I have to add 4 to both sides. So it leaves me with 1/3 x. 1/3 absolute value of x equals 9. And the next step, I need to get rid of the 1/3 from here. So I'm going to multiply both sides with 3 over 1, the reciprocal of the fraction. And that will leave me with, that's a 3 over 1. That will leave me with absolute value of x equals 27. Now, if I have absolute value of x equals 27, where can the x be on the number line? Well, there's really two spots that x can be on the number line. The x can be here, because even if it's here, the absolute value will be equal to 27 because absolute value is the distance from 0, or the x can be here. So now we're ready to split this equation. We're going to say either x is equal to 27 or x is equal to negative 27. And these are our two solutions for this absolute value equations. Most of the absolute value equations will have, absolute value equations will have two answers with the or in the middle. That means x can equals 27 or x can equal negative 27 here. Absolute value equations will always have two solutions. Okay, let's check out our next one. Next, problem number 2. Here I'm going to isolate the absolute value symbol first. So that means I'm going to subtract 26 from both sides. What's 26 take away? What is 9 minus 26? So that would be 26 take away 9, and then sign of the bigger number is going to go in the front. So that is negative 17. 26 take away 9 is 9 take away 26 is negative 17. Now, some number whose absolute value is equal to negative 17. This one is a tricky problem. Now, we just talked about the absolute value is the distance from 0. Absolute value of a number is distance from 0. And the distance is never negative. Distance is never negative. So that means absolute value of a number can never be negative. Absolute value of a number can never be negative. So here I'm trying to say absolute value of something is negative. That means there is no solution to this problem. Now I'm not going to split it into two equations. Because absolute value of any number is its distance from 0, and the distance is always positive. Distance is never negative. So absolute value of a number cannot equal to a negative number. That's why there is no solution in this case. Absolute value of any number, it can equal 0. If I'm talking about the number 0, then its distance from 0 will be 0. Any number is always positive. It is never negative, okay? Never negative, always positive. So it's never negative. If it turns out to be that you see it is negative, that means there's no solution to that equation. Here we are with example number 6. My first goal is to isolate the absolute value. I'm going to make it a little bit better here because I think let's do this. I'm going to isolate the absolute value first, absolute value symbol. So looks like I need to make this 1/5 go away from here on the left hand side. How would I make that 1/5 go away? So I'm going to multiply both sides with 5. 1/5 times 5 is gone, and I'm left with 3 minus 6x. Absolute value is equal to 15. Now what this is telling me is that there is a number here, some number, whose absolute value is 15. Where can that number be on the number line? Really, that number can be sitting over here, because then its absolute value will be 15. Or that number can be sitting over here. Again, its absolute value will be positive 15 then, even if it's sitting at this spot. The absolute value will be positive 15. So once we have isolated the absolute value, we are ready to split it into two equations. We're going to say either that number is equal to 15 or that number is equal to negative 15. Now we're going to be solving two separate equations, okay? Let's take care of the first one. If I want to isolate the x in here, the first thing I would do is subtract a 3 from both sides. Negative 6x equals 15 take away 3, which is 12, and then divide both sides with negative 6. X is negative 2. So that's my one solution. And your solution to an absolute value equation can be negative. The x can be negative, okay? But the absolute value in itself cannot equal a negative number. Keep that in mind. There's a distinction here. Next equation, the next one we said, the 3x minus 6 can equal negative 15. So I'm going to subtract 3 from both sides. Negative 6x equals negative 18. Divide both sides with negative 6, and x equals 3. So there's two possible answers that will make this equation number 3 true. Equal, the left side will be equal to the right side. The original equation was 1/5, absolute value of 3 minus 6x equals 3. So two numbers will make the left and right hand side equal to each other. Those numbers are x equals negative 2 and x equals 3. Of course, for your peace of mind, plug it back in, plug both of them back in and check. But if you did the work correctly, then they both should work out correctly. Okay, that's the end of this video.